Okay, so there is a variety of kind of questions that you could be asked, kind of word problems. Sometimes you're given the triangle, sometimes you have to draw your own triangle, and sometimes you have to do two triangles. So you have to solve one thing and then solve something else. So we're going to go through different types of questions. All of them will have a right angle, so they're all going to deal with SOH CAH TOA. So, like I said, sometimes you're going to have to draw a label diagram. Even if they give you sort of parts of the diagram, you're still going to have to make a triangle and label the sides and the angles. So even if they give you sort of the pieces of it, you're still going to have to label it, whether you like ABC or whatever. You're going to have to make a triangle. You could have to include a let statement so that you are, again, sort of letting your reader, your marker, who is me, know what you're solving for. And of course, you have to show all of your work and then make sure you have an answer statement. And when you do problems that have more than one triangle, then often you'll be given a part of a big triangle side and you have to add it together. Like there's often kind of one step at the end to make sure that you answer the question. Okay, so this one is not a traditional word problem, but we do need to draw the triangle, okay? So even if you don't use a ruler, that's fine, but you want to make sure that you sort of have some kind of right angle looking thing. Oh, it says B is 90. This is 7.6, yes. I think, isn't it? Okay. So this is sort of the old way that you're used to of labeling sides. So it says AC is 4, BC is 1.5. Okay? So when we do trig, we use capital letters for the angles, capital A, capital B, capital C. And there was one question in the homework already like this, but tomorrow when we do non-right angle triangles using the sine law and cosine law, what we're going to do is we're going to use little lowercase letters to represent the sides. So another way you can do this is that this side is A, across from B, angle B is B, and then this is side C. You can use X, you can use theta, it doesn't really matter. In this case, it asks you to solve the triangle, so that means we need to find all the side lengths and all the angles. And you have, there's a variety of ways to answer these questions. So right now, we could even use the Pythagorean theorem to find side C. So you can kind of choose what you want to do first and what you want to do next. So I'm going to stick with grade 10 concepts. I'm not going to use Pythagorean theorem, okay? But you can. But let's use the ratios we learned this morning, okay? So side B, or 4 centimeters, no matter what angle we're talking about, what is that? Hypotenuse. So you can call that the hype. So side A, or 1.5 centimeters, could be the adjacent side to angle C, or it could be the opposite side to angle A. So it actually doesn't matter. So I'm going to pick this angle first. So I'm going to do angle A, so then this is the adjacent. Angle C, sorry. So that's the adjacent. So if we're going to do C, find angle C, and we have adjacent and hypotenuse, then that's cos. Yep. We don't need units because the angle does not have units like centimeters. So now, practicing what you did this morning, decide what you like to do. Do you want to do the 1.5 divided by 4? Do you want to leave it all as 1? Decide what you want to do. If it doesn't say, you can choose. Okay, so to get rid of the cos, we have to do cos inverse, right? And you should get 68. Degrees. It's an angle. So what I would do now, so that you can see where to go from here, put the 68 in the triangle so that you know where it goes, okay? And we can, again, there's a variety, you can do a variety of things to solve for the other side. You can easily solve for the angle. Because the total has to be 180. You could have also done sine, because 1.5 is opposite to 22 to angle A or 22, so you could have done that too. So there is a variety of ways to get these answers, okay? So now, yes, if it says solve the triangle, oops, let's add a triangle in, sorry. If it says solve, then do all the side lengths and all the angles. And usually this question, like say it was just an X, it would be out of like 2 or 3. This question would be out of more. So that's another way you can tell. Yeah, for sure. Yes. No. And when we do triangles tomorrow, there will be no right angle. So when you label a triangle, capital letter for the angle, and across from it is the little b is the lowercase, and that's the side. Okay? It's because the Pythagorean theorem is c squared plus a squared. C squared equals a squared plus b squared. So then labeling it c is important, but now it doesn't matter. And tomorrow we won't have a hypotenuse. Okay, so now we have to do c. So again, I'm going to use what we used this morning. So now we have 68. I'll stick with that. So if I look at 68, then this side over here is opposite. And you actually have a choice. Now we have the hypotenuse and we have the adjacent. So you could use sine or tan. If you have a favorite ratio, you pick what you like. I'll just use sine. So again, if you don't like that it says sine in letters and you want to make the sine 68 a number, you can do that. You can keep this here to get the 4, rid of the 4 to isolate the c. We got to multiply. So sine 68 times 4, or 4 times sine 68. It's not 68 times 4 and then do the sine of that. Okay, so be careful of that. Don't do that. These cancel. And it does say centimeters, so we should use centimeters. If you want to fill it in so that you know I solved for all the angles and now all the sides as well, you know you're done. If your work is nice, then a question like this, you don't necessarily need an answer statement for. Okay, so this question is very, very common. Something's happening and there's a staircase. So the staircases, if you think about a staircase, there's an angle to a staircase. A truck or a car drives up a road. The road always has an angle. A truck is trying to be like, you have a tow truck and the car is trying to drive up the ramp. Okay, so these questions are very common. Part A is a little bit ruthless. I believe it was something, this was a question, or there was a question like that in the homework, so I left it in there. But it doesn't matter, we can figure it out. But in this case, it is important to draw a picture, okay? Obviously, there's no triangle here. We need a triangle, okay? So the distance between two floors in a new home is 2.5 meters. And so what you might find sometimes is you'll get a weird question like this. Okay, so let's make the ground, or the floor 1. And floor 2. So when you draw two lines like that, that does not look like a triangle, okay? So sometimes when you draw a picture, there's going to be extra stuff that you don't necessarily need, okay? So now it says the distance between two floors is 2.5 meters. So here we have the upper floor and the lower floor is 2.5 meters. Hopefully your floors are level, so then this should be a right angle. And you can kind of see, hopefully, whether you draw, I drew the end of the triangle here. You could have drawn it over here. That's fine. And then what you're going to do is you're going to make a triangle. No, question A is only asking for the rise over run. So it's kind of weird. I left it in there, but I think that was from the old book. It says, yeah, exactly. The horizontal length of the staircase is 2.8 meters. So you have to think of where would the staircase, the horizontal length, okay? So horizontal is along the ground, okay? This is not horizontal, right? That's diagonal, okay? So sometimes the wording can be weird. So the horizontal length has to be horizontal, not diagonal. No. Okay, this is weird. I promise this might be from the old book. The slope is rise over run. It is actually easy. No. Maybe you'll need it next year. That's all you have to do. That's it. Yes. So now again, you have some choice, okay? So B says, determine the angle of inclination of the stairs. So we have the floors, we have the distance between them. Where would the stairs be? They would be here, right? These are the stairs. So decide what you want to do and then write a let statement. So you could call this theta and then say, let theta be the angle of inclination. You could do, yep, but then write let x be, whatever. You could do this, something like we did before, and then say let angle C be the angle of inclination. You decide how you want to label your picture, and then just write the appropriate sentence, the let statement, okay? I do recommend that you still label the opposite and that kind of thing, okay? So here, if we're going to do, I called it theta, whatever you called it, x, angle C, whatever you want. So this side here is adjacent, and this side here is opposite. Adjacent is next to it. Opposite is opposite, like across. Okay? So opposite and adjacent is tan. So I use theta. If you use C, if you use x, write tan x, tan C, whatever you did. Tan is a very common ratio that you need to use for word problems. Not always, but it is common. And often what happens is lots of people, what they'll do is they'll just find the length of the hypotenuse, they'll find what theta is, and that's great. Just make sure then your answer statements reflect your answer, okay? So here it doesn't ask us for how long the stairs are. I could have asked you to do that, and then you would be finding the length of the hypotenuse. All I've asked for is theta. Just make sure you're answering the question and that I know, the marker knows that what you're answering, okay? Yep. It doesn't say, so if you wrote 42, that's okay. No, because it doesn't say. If it says, then just make sure you read the question carefully, okay? Okay, the next slide has a couple of definitions. So the big thing with angle of elevation and angle of depression is you always have to be thinking about the horizontal. Okay? So when you have elevation, it's going to be in relation, like elevations up, yes? So think about a horizontal and an angle up, and then depression is down. It's an unfortunate analogy, but say you're depressed, you feel down, okay? Then you're going to go, like if you're looking, then you go down, but it's always in relation to the horizontal. So a very common question is, this is supposed to represent a person. They're looking out, what's the angle of depression? But you always kind of need to think about this horizontal. So the angle of depression, like if their eyes are here, then the angle of depression goes down. And now you can see, oh, I see, here's a triangle. Okay? So we need this horizontal so that we can make a triangle. That's the way the angles are measured. So a search and rescue airplane is flying at an altitude of 1,200 meters towards a disabled ship. The pilot notices that the angle of depression to the ship is 12 degrees. How much farther does the airplane have to fly to end up directly above the ship? So, as soon as you see angle of depression, angle of elevation, what I would do is draw a horizontal. And then it says angle of depression. So we're going to go down. It doesn't matter. I'm going to put my pilot here. You can put your pilot over here. It doesn't matter. And then it's down. So I'm being depressed from the horizontal. I'm going to go this way, down. And now we have a triangle. Is my triangle to scale? No. Is it perfect? No, but I did my best. The big thing is the angle of depression from the horizontal. So that's this here from the pilot. Yes. Do you need to do that? No. You could do ABC, you could do XYZ, whatever you like. Yes, I was just going to say, what do we want to label next? Airplane or the ship? So the ship is below the airplane, obviously, that makes sense. So I'm going to call the ship S. Now, this question is weird. So we're trying to find where the airplane should go. So theoretically, the pilot's in the airplane, right? So that's where it is. We're going to find where it needs to go. So because I've drawn my ship here, then I'm just going to call this A for airplane. That's where the airplane should end up. Or you could put like, let A be the point directly above the ship. Whatever, that makes sense too. Whatever makes more sense to you. The more descriptive your let statements are, and especially in a case like this, then that might help you figure out what I'm trying to find, right? So we're given 1,200. So that says the search and rescue airplane is flying at an altitude of 1,200. So even, let's say you want to make the fanciest picture possible. So the ship would be in the water, right? So say the water's down here. You might think, well, Ms. Todd, but that to me, that means that if the airplane is 1,200 meters above the water, wouldn't that be this distance here? Sure. But is this and this the same? If I drew a straighter line? Yes. Okay? So you can do stuff like that too. So you can say, okay, well, this would be 1,200, but so would this. That makes more sense to you. Okay? You can make your picture simple. You can add in as many details as makes sense to you. Okay? Because I already used blue. I know. I'm sorry, Claire. It's a dirty ocean. So now you have to decide which side are we trying to find? Are we trying to find the hypotenuse or up here, right? But remember, read what the question says. How far does the airplane have to fly to be directly above the ship? It's not trying to fly to the ship. It doesn't want to crash into the ocean. It wants to fly above it, okay? Even if you think of it logically, does it make sense for a search and rescue plane to fly to the ship and crash into the ocean? No. It makes sense. They're going to fly, let a what are those called? Ladders down and get the people out of the ship, okay? So now I'm going to use the 12. You could solve for this angle here if you wanted to, but again, that's an extra step that you don't need. So we have this angle. So this side to it is opposite, right? And then this x is adjacent next to it. And again, we're going to use tan. So like I said, that is a very common thing in word problems to use tan. And now we have a situation where we have one of those extra step ones. The x is in the bottom. So we have to multiply and then divide, right? Yeah, you would just do this is adjacent and no, you can't do 90. Can't do 90. And then you could use this one if you did 180 minus 90 minus 12, because here then they'd both be beside like which one's opposite. Doesn't work. So again, you can decide, actually I'm going to rewrite this. Do you want to make tan 12 a number or yes? Sure, let's do it. I'm just going to keep 4 decimal places, but again, it doesn't really say, so it doesn't really matter. Okay, now we have a number with x, which is multiply, so you have to divide. These cancel. That is a big number, but it's we already have 1200. That's a pretty big number. So when you do a word problem, because you're talking about distances often, then the numbers can be big. That's okay. No, absolutely not. Nope. To be honest, what I did was tan 12, pushed equals, and then did 1200 divided by answer. So I actually didn't round when I did the math. So you're good. 105. Okay, so for the next one, we're given like kind of half a picture. And maybe you can see the triangle, but again, you want to make sure that you either over top of the picture draw the triangle and label it, or you can sort of sketch it on the other side or beside it. So again, traveling up a road, this is a really common question, similar to the stairs with the inclination. A construction engineer determines that a straight road must rise vertically 45 meters over a 250 meter distance measured along the surface of the road. So you have to think about the surface of the road. Now this question says that that is the hypotenuse of the triangle, and then you're going to calculate the angle of elevation. Do a better job than me. Or you can draw your triangle right over top. It tells you that the road, yes, yes. It tells you what the surface of the road is. It tells you that it's the hypotenuse, that this is 250. And vertical, right? Up and down. So some of you on your chapter 5 test, I was like, oh, they're going to be so annoyed with themselves. You would literally write things like horizontally shift down 5. Up and down, that's vertical, right? This way is horizontal, which is, so you do kind of have to remember that as well, okay? So vertically, not horizontal, vertical distance is 45. And we're looking for the angle of inclination. So again, if you want to label it ABC, you can use theta, you can use X, whatever you decide to do, just include that in your let statement. Yeah, like tan X, sine X, whatever. Yep. Okay, so go in. This is across from the right angle. That's the hypotenuse. And then we're going to do theta. So that is the opposite side to theta. We don't need to find how the horizontal distance, but you could solve for that using Pythagorean theorem, and then you could use that side, but again, that's more work than you need to do, okay? So we just need to use sine, that's fine, sine theta or sine x or whatever you decided to call the angle. The hypotenuse has to be the longest side, so you can kind of check your ratio before you do your math. You would never have 250 over 45. It's always 45 over 250. Or sorry, the bigger one has to be in the bottom. It has to be the hypotenuse is the longest side. So then to isolate theta or get rid of the sine, get rid of it, you have to do the inverse, which is sine to the -1. Actually, this time I'll show you the math. Usually when you have a road, it's not a very big angle, which makes sense. You don't want, like, you think about roads, right, in a real way. They're not usually very steep. Not safe roads anyways. Yes. No. Okay, so again, sometimes you're given pictures like this, so you can kind of see it's got 3 points. It's got the startings of a triangle, okay? So Jackie works for an oil company. She needs to drill a well to an oil deposit. The deposit lies 2,300 meters below the bottom of a lake, which is 150 meters deep. So sometimes there are questions like this, okay? So let's draw some lines in. So here we have Jackie to the lake. And then the lake to the oil deposit. But this time, sometimes it'll say, it could have said, you know, at like the bottom of the lake to the oil well is 1,230 meters, which is fine, except it's telling you also that the lake is 150 meters deep. So it makes sense that Jackie is not at the bottom of the lake, right? She's at the top. So you do have to take that into consideration too. So where Jackie is to the top of the lake, and then so you have to consider how deep the lake is, which is 150. And then from the bottom of the lake to the oil is 2,300. Yes. So now the total length of this side, you have to add them together. I will show on my work so that later you can figure out where I got this number. So we need one more side. So again, try to read the question carefully. The site is 1,000 meters away from a point directly above the deposit. So this is Jackie. If it said the oil deposit is 1,000 meters from Jackie, then you would be the hypotenuse, but it doesn't say that. It says 1,000 meters from a point directly above. Okay? So you do have to make sure you're reading carefully. And then, depending on what it's asking for, if it asked for the length from Jackie to the oil, then maybe you would want to label A, B, C, D. But we're just asked for the angle. Actually, it doesn't even have a question. Yeah, but let's make a better question. Or from the site, from where Jackie's standing, something like that if you want. Okay, so then you could even call it the angle of depression because it is from a horizontal, so that's legitimate as well. No, to be honest, the stuff that's in black, I would give you. This would be already in there. You don't have to try to figure out what you're supposed to find. Now these questions, again, if you think about what this question's trying to ask you, then logically it makes sense. If you're a person who's going to drill, then you're going to figure out the angle where you should put your drill bit or whatever, as opposed to trying to finding this angle down here. Practically, what do we need that for? Okay, so it's easier to measure the angle from where you're from, where you're standing, anyways. Okay, so this 1000 is next to it, so this is adjacent. This side over here is opposite, and the way that they have worded this question, you need both together. Okay, so you need the whole side. Not sine, sorry. So we're going to do, we have opposite and adjacent, so that's tan. Okay, so again, you can skip this step in the right here. If you can go put this in your calculator using brackets, that's fine. But then remember to write an answer statement. Okay? And then you can do problems that actually have two triangles. So a common situation is something like this, where you have a person who's a rescuer, somebody's above in an airplane, helicopter, and then there's something below. So you get sort of two triangles this way. There's also a really common one is there are two buildings. One of them is taller than the other. Usually you're given the distance between them and you have to find the angle of depression or elevation or something. So you kind of draw two triangles that way. That's also another common problem. So, but we're going to do one like this. So Nadia, whose eyes are 1.65 meters off the ground, is standing on a cliff 130 meters above the water. So it's up to you how fancy you get, because really what you can do in a really simple way, if you have Nadia, you don't need to draw a stick figure or anything like that. She's 1.65 meters tall. And then the cliff, oh, 130, sorry. Oops. Okay, so you don't have to draw a fancy stick figure. You don't even have to draw a stick figure. You don't have to draw a fancy person, nothing. Nadia is 1.65 meters. The cliff is 130 meters above the water. So Nadia looks down at an angle 57 degrees from the horizontal. So again, draw in your horizontal, okay? It does say she's looking. I'm going to draw my horizontal dotted, but you don't have to. So here, like, if you think about Nadia, her eyes are up here. So we're going to actually, when it says horizontal, I would draw one in to help yourself. Okay, so from the horizontal, it's 57 degrees. So here's the horizontal, 57 degrees. To see Colton in the water. So it's up to you. You can call this N for Nadia. You can put Colton down here. So yeah, so if you want, so let N be Nadia. Let BN be an, oh, woo. That's some good writing there. About to be eaten by sharks. Then Nadia looks up at an angle. Okay, so this stinks because I'm going to draw over top, but that's okay. Looks up at an angle of 46, again from the horizontal. So here's the horizontal, and she is looking up. Oh, that's pretty long. Sorry. From the horizontal to see Robert. Because this is a two triangle problem. So you can write R, you can write helicopter. Robert is directly above Colton. So when it says stuff like that, like directly above, then that's kind of a clue. Oh, I think there should be a right angle. Okay. And due to weather conditions, he cannot lower the helicopter any further. Robert wants to help save Colton by sending down the 220-meter long rescue ladder. So that means that from Robert to Colton, has to be 220 meters. Will the ladder be long enough to save Colton? So the ladder is 220 meters. Do we know if the distance from here to here is 220? No. So let's find that distance and then we'll see if they're the same. Is it 220? So probably what you want to do is you could label them X and Y. You can kind of see, oh, I have two little triangles. After tomorrow, we're actually going to look at a triangle when they're not a right angle. So there is actually another way, once you're done this unit, that you would be able to solve this. But for now, we're going to do triangle 1, triangle 2, and add them together. Okay? So like I said, that's a common thing in these word problems, where you find one side, find another side, add them together, or subtract them, or something like that. So I'm going to do... It doesn't really matter. I'll do X first. What did I do? So I'm going to do 46. So this is opposite. Oh, wait a minute. I don't know what the adjacent is. So then, I know it's weird, but technically, we know how tall Nadia is. We know how far away she, like this distance here. So we know what Y is. So it's like a little puzzle. Just keep writing, filling things in. So now I'm going to solve for the adjacent or the horizontal length first. When you do these problems, there has to be a common side, okay? So like this one, the horizontal is same in both triangles. So now if I do 57, so this is opposite. So again, if this kind of thing bothers you, you could call this a variable. You could call it H for horizontal. Whatever you want to do, you can leave it like this. We still, again, it's in the bottom, so it's the same. We have to do a two-step thing. Multiply first. Then divide. You can change tan 57 into a number. Either 56 or 63. Probably 56. So if you want, go fill it in here. So now I have adjacent to 46 and the opposite is x. So I'm still going to use tan, which again is a really common thing in these word problems. I don't want to squish anymore, so I'm going to go to the next slide when I can. Yes. It's 46. Right? The good news is now it's the easy one where you just have to multiply. Yes, Kylie. I changed tan 57 into 1.54. So if you like to leave it like that, then you can. You don't have to show that step. And finding this, finding the horizontal, finding the other distance actually doesn't even answer the question. So we still have to decide, is the ladder long enough to save the boy? We haven't even done that yet. So obviously this is a lot of work. Then I can't ask you like 5 of these questions, right? So the double triangle word problems are a little bit trickier. But as you go through it, just keep filling stuff in, okay? So now we have this distance is 131.65. We're looking for this distance to add it because we want to see, is this total 220? So it's a tiny, teensy weensy bit longer than 220, but still, Colton, shark bait.